In this video, we're going to cover section 3.3, which is on dividing polynomials and using the remainder and the factor theorems. So there are two ways to divide polynomials. First being long division. This method works all the time, but it can be long and tedious, so I'm just going to kind of review how it works. Hopefully you've done long division problems before. You will not need to use this very often, but there are cases where it's necessary, so we do need to review how it works. So let's say we have the polynomial 6x to the third plus 17x squared plus 27x plus 20, and we need to divide that by 3x plus 4. So to set this up for long division, the 3x plus 4 is going to sit outside of my division bracket, and then underneath the division symbol, we put our 6x cubed plus 17x squared plus 27x plus 20. All right, we start by looking at the first term here. Make sure that your order of exponent is highest to largest, and if there's any terms that are missing, we put in a 0 coefficient for that term. Okay, this one did not have any missing terms. So once we have it set up, we're going to take our first term here, 6x cubed, and divide it by the first term out here, which is 3x. So 6x cubed divided by 3x would be 2x squared. So that would go up on top. So we'd start by putting our 2x squared right here. Once you put the number on, or the expression on top, then you're going to multiply it by the entire expression out in the front. So 2x squared times 3x is 6x cubed plus 2x squared times 4 is 8x squared. Next step is to take that entire quantity and subtract it. So subtracting it means distribute your negative. So negative here would make these cancel, and then negative times the positive would mean a minus. So 17x squared minus 8x squared is 9x squared. Next step is to drop down the next number. So we drop down the 27x. We do the same process again. We take 9x squared and we divide it by 3x, which 9x squared being divided by 3x gives me 3x, so that goes on top. 3x times 3x is 9x squared right here, and then 3x times 4 would be 12x. Parentheses go around this expression and you're subtracting it. So subtracting 9x squared would cancel here, and then distributing the negative makes this a minus. So 27x minus 12x is 15x. Next step drops down the 20. Do the process again. 15x divided by 3x is 5. 5 times 3x is 15x. Plus 5 times 4 is 20. Again, the entire thing gets subtracted. So distributing the negative cancels the 15s, and then makes this a minus, and 20 minus 20 is 0. So this is our remainder, and what we ended up with on top is called the quotient. So our answer, we would write down our quotient plus the remainder divided by the expression outside of here. You probably don't need to necessarily put this part, but if there's a blank in my math lab in the template to type a number here where this is already given, you would just put your remainder on top. If it's not a 0, it definitely needs to be part of that. All right, so most of the time when we have to divide for what we're going to use division for in this course is we're going to use synthetic division. Okay, synthetic division is a shortcut to long division. However, it only works if you're dividing by x minus a number or x plus a number. So in the previous example, we were dividing by 3x plus 4, so we couldn't have used synthetic division there. All right, so for this example, we're going to try synthetic division. So we got x to the fifth plus x to the third minus 2. We want to divide it by x minus 1. So we're dividing by x minus a constant. So to set up synthetic division, we're going to look at what we're dividing by, and we're going to find it's 0. So in other words, if I set this equal to 0, I would get x equals 1. So that number goes outside of this little bracket. Then in the row right here, we're going to line up the coefficients in order of decreasing powers from the numerator. So the highest power of x is 5. So we start with its coefficient, which is a 1. Then it would be the fourth power of x, which is missing. There is no fourth power term, so we have to put a 0 for that spot. Then the third degree term coefficient is a 1. The second degree term is missing, so we have a 0. The first power of x is missing, so we have another 0. And then the constant term is always last, -2. So we should have a fifth power, a fourth power, a third power, second power, first power, constant. All right, so our first step is to take this first number and drop it straight down below this line. Then you're going to multiply what's out here by the number down here. So 1 times 1 is 1, and it goes right here. Then we add. So 0 plus 1 is 1. And we continue that same process until we've gotten all the way across this setup. So 1 times 1 is 1, it goes here. Add, that's a 2. 2 times 1 is 2, it goes here. Add, that's still 2. 2 times 1 is 2 again, it would go here. Add, 2. 1 times 2, 2. Add, 0. So once you have this bottom row filled in, the last number is blocked off because that always represents the remainder. We happen to get 0 again this time. These other numbers represent the coefficients of the quotient. Okay, so these are the coefficients of our answer, but you also have to remember that if you are dividing an x to the 5th polynomial by a first power, you're only using synthetic division if you're going to be dividing by a first power of x. So the answer is going to be one less degree than what we started with. So if I had a 5th power and I was dividing it by a first power, my answer is going to be a 4th degree polynomial. So these coefficients, this first number is going to represent the coefficient of x to the 4th. So 1x to the 4th, and then they go in order. Plus 1x cubed, plus 2x squared, plus 2x to the 1st, plus 2. Since the remainder is 0, I didn't put anything at the end. If the remainder was not 0, say the remainder was 2, you would have 2 over x minus 1 at the very end. So it saves you a lot of time, doesn't take as much paper to write it all out. It's just a little bit of a quicker method. All right, let's try another one by synthetic division. 5x squared minus 12x minus 8 divided by x plus 3. So we're dividing by x plus a number, which means I can use synthetic. My 0 of that is -3. So we put -3 out here. 5, -12, and -8 are the coefficients in order. First step, drop down the 5. Multiply by -3 and get -15, and it puts right here under the -12. Add -27. Multiply would be +81, would go here. Add 73. This last number is always the remainder. These numbers here would be coefficients of my quotient. So if this was a second degree polynomial and I was dividing by a first, my answer is a first degree. So this would be 5x to the first minus 27 plus my remainder was 73, and it always gets put on top of what I was dividing by. So 73 over x plus 3. All right, so we'll get back to using that here in a second to talk about polynomial zeros, okay? The next part of this section is using what we call the remainder theorem. The remainder theorem is a way of evaluating a polynomial using synthetic division. So it says the following. If a polynomial f of x is divided by x minus c, then the remainder is f of c. So if we're given a polynomial and told to use the remainder theorem to evaluate it, say find f of a number, the number that you're wanting to plug in goes out here, c. You'd line up all your numbers here, you drop down, right, do your synthetic division, do all the work, and you'll get some number at the end. This remainder is the value of f of c. That's what the remainder theorem says. So it's the same number you would get if you plugged c in place of x into your original function, like we have been doing before. All right, so let's try this example. Use the remainder theorem to evaluate f of x equals 6x to the 4th plus 10x cubed plus 5x squared plus x plus 1. And we want to evaluate f of -2/3. All right, so we're going to take the -2/3 and put it outside of my bracket. We're going to line up our coefficients like we would for synthetic division. So the 4th power term coefficient is 6, 3rd power is 10, second power would be 5, the first power coefficient is a 1, and then the constant is a 1. So we drop down the 6. You multiply negative 2/3 times 6, and that would give you negative 4, and it would go here. Add. Multiply negative 2/3 times 6, which we just did. It's negative 4 again, so it goes here. Add 1. Negative 2/3 times 1 is negative 2/3. 1 minus 2/3 is 1/3. 1/3 times negative 2/3 is negative 2/9. And then 1 minus 2/9 is 7/9. So this answer that we get as the remainder is the value of f of negative 2/3. So f of negative 2/3 would equal 7/9. You could also check that on your calculator. If you plugged in negative 2/3 in place of x within this polynomial and got an answer, it should be equivalent to 7/9. All right, this next example is asking us to use synthetic division to divide this function, polynomial function, by x plus 1, then use the result to find the remaining zeros. All right, so if I'm dividing by x plus 1, the zero of this is negative 1. So that's why we would start with a negative 1 out here. Coefficients would be 1, negative 2, negative 1, and 2. So our first step would be drop down the 1. Multiplies negative 1 would go here. Add negative 3. Multiply positive 3 goes here. Add is a 2. Multiply is a negative 2 would go here. Add is a 0. All right, so that brings us to our last theorem that they talk about called the factor theorem. And it says when the remainder is 0, then the x minus c or x plus c, whatever we were dividing by, would be a factor of the polynomial. So our goal here is to use synthetic division to help us identify factors, which in turn will let us identify zeros. So we're kind of learning a way of being able to factor a polynomial if it doesn't factor by a method that we have learned before. Like if the grouping method does not work, right, or it's not factorable the way you learned it in previous courses, this is another way of figuring out how to get it factored. Okay, so since we got a remainder of 0, right here means that the x plus 1 is a factor. So in other words, this negative 1 out here means that one of my factors is the x plus 1. These numbers represent the coefficients of what would be a second degree polynomial, because remember I started with a third degree. So this would be 1x squared minus 3x plus 2. Okay, so when it says use the result to find the remaining zeros, this is the result, right? My remaining zeros come from finding the zeros of this thing. So this I can factor myself. X minus 1 times x minus 2 would be the factored form. So my original polynomial factors into these three factors. So my zeros all together would be negative 1 from this one, positive 1 from this one, and positive 2 from this one. Notice it was a degree 3, and I ended up having 3 zeros. That always happens. All right, this next couple examples are essentially doing the same, it's just the question is worded a little bit differently. So for this one, it says solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that negative 2 is a 0 or a root. So if they give you a 0 or a root, they're telling you that when you do synthetic division with that number out here, that you're supposed to get a 0 as the remainder. So we start with that. Negative 2 would go out here because they're giving us that that's a root. Coefficients of my polynomial would line up here. 2, negative 3, negative 11, and 6. Do the synthetic division. Drop down the 2. Multiply is negative 4. Add is negative 7. Multiply positive 14. Add is 3. Multiply is negative 6. Add is 0. This should not be a surprise if it says given negative 2 is a root. Okay, if you don't get a remainder of 0, then you did something wrong, if that's what it says. All right, but more importantly, we're asked to solve the equation, so we have to take this a little bit further. So negative 2 is a root, meaning x plus 2 is one of my factors. The result, 2, negative 7, 3, represents the polynomial 2x squared minus 7x plus 3. This quadratic, we can factor ourselves into 2x minus 1 and x minus 3. So now we have it completely factored. So this factor leads to the 0, negative 2. I knew that one because I was given that. This factor, if I set to 0, I would add 1 and divide by 2, right? So 2x would equal 1, so I get 1/2. And this one set to 0 would give me 3. So if it asks for a solution set, you might have to write it like this in the set braces with commas, but negative 2, 1/2, and 3 would be my solutions. All right, this last one right here is similar. It's just instead of giving you a root and stating what it is, it's asking you to identify it from a table or a graph. So it says solve the equation by using the table provided for this function. Okay, so this table given is for the function that they're asking us to solve. Or in the next section, we're going to talk about graphing it on the calculator and looking for the zeros that way. So if I'm looking at a table, we're looking at the y column, right? When y is 0, that's what we're trying to identify, right? So y being 0 is right here, came from the x value of 1. So from the table, I can tell that x equals 1 is a 0. So that tells me to start synthetic division using a 1 out here. So I put the 1 out here, 6, negative 11, 6, negative 1. Drop down the 6, multiply 6. Add is negative 5, multiply negative 5, add is a 1, multiply is a 1, add is a 0. So the 1 being a 0 means x minus 1 is a factor. 6x squared minus 5x plus 1 is the other polynomial. This factors then into 3x minus 1 and 2x minus 1, which means my zeros are 1. So setting this one to 0 would give me 1/3, and then if I set this to 0, I get 1/2. All right, that is the end of section 3.3. In the next section, 3.4, we're going to be doing pretty much the same thing that we did here, only they're not going to give us a root or tell us where to start. So we're going to learn how to start from scratch.